Okay, so for today and tomorrow, we're going to be working on this little applications of kinematics and vectors activity involving some maps. Okay, this is something you're going to do with a group, so you're going to have to be masked up while you're working with your group members. Okay, and I have made copies of everything for everyone in the group, so there should be no like sharing of papers or fingering up of other people's stuff. Okay, we need to keep this as separate as possible, okay, so we can avoid spreading anything. All right, so just know that that's going to be a little weird. That's not normally how you would do group work, but this is COVID group work, so we have to do it that way, unfortunately. Okay. So what I'm going to do here first is I'm going to hand out this sheet and the maps to you, okay, so you can kind of follow along with me and see what we're going to be looking at. You and your group are going to work on this today and tomorrow. You should be able to realistically get it done, okay, in class and not have to worry about getting together with your group outside of class time or anything like that, because I want to try to avoid that if we can. Okay, and then obviously you have your unit exam on Wednesday. Okay, if you've got questions or anything, okay, I'm available for help today at lunch, but tomorrow I have supervision all through lunch hour. So if you need help, you're going to have to walk outside with me. And I've been trying to help you, but okay, you have to walk around outside with me to get in order to get it. Okay. All right. So I'll hand those out here, and then we'll. All right. How many of you have used a topographical map before? That's what I thought. Google Maps has ruined an entire generation of people about how to use a map. Nobody uses a topographical map anymore. Okay, but this is an important skill. Okay. So on a topographical map, okay, what you have, okay, I'm just going to zoom in on here, okay, is you have all these little curvy lines. Okay, the curvy lines are there to represent three-dimensional space on a two-dimensional piece of paper. Okay, so every one of those lines represents a change in altitude. The closer together they are, the steeper they are. Okay, so in a place like this, right here, where the lines are fairly far apart, that would be, you know, a slope, but not something like, let's say, right here, where those same topographical lines are basically stacked on top of each other. That is called a cliff. Okay? So, when you are planning your routes along this map, you kind of have to look at those lines. You don't have wings, okay? And so you can't just go off cliffs, because that will be where your trip ends. Okay? There'll be a broken pile at the bottom. Okay? We don't want that. We want you to pick safe routes, okay, from place to place, okay, on this map. So that's something you have to consider. Okay? All the little blue squiggly lines are streams. They're not too bad most of the time, but they can be a little bit tricky if they're fast or deep or both. Okay, crossing them can be a bit of a problem, so that's something else you have to consider. Okay, anywhere where you see dotted lines, those are trails. Okay, those are good to walk on. They're, you know, generally free of obstacles. Okay, and then the red line is actually a road. Okay, so you can see that on, I think, through all three maps. Okay, that's a road. Right. So what you're going to be tasked with, you and your group, is to plan your route along these points. Okay, if they don't show up, and I know point number 3 is kind of hard to see because it's right at the seam of the map there. Okay, you might just want to draw these back on. Okay, so you're going to start down here at Moline Lake. Okay, and you're going to be going to cabin 1 on your first day. And then on day 2, you're going to go from cabin 1 to cabin 2. Okay, day 3, cabin 2 to 3, 3 to 4, and then you're going to end over here at 5. Right? So the first thing you have to do is plan your route. Okay? And so all I'm asking you to do there is pick the most logical way to get from one place to another that's safe. Okay? So on like day 1, there's a path that goes all the way from start to cabin 1. So the most logical thing to do would be to walk along that path. I see a bunch of people frowning at their paper right now. There's a little dotted line that runs from start to cabin 1. All right, so if I was being, you know, logical about this, I would probably just follow that path. I can't even see it on my map because it's so small, but it generally does this. Okay, so I would simply draw that out. Okay. Then I would have to plan how I would get from cabin 1 to cabin 2. Because I made sure that I cut the map off at the top so that you couldn't follow a path all the way from 1 to 2. Okay? But you would have to do a little bushwhacking. Okay? And go a little bit off trail. Okay? Right here near the top. Okay? I cut it off so you can't see the path anymore. So you'll have to pick a route, which isn't too hard. Just, don't fall off any cliffs. And try to avoid crossing too many rivers and things like that. Okay? On your way to cabin 2. And then similar, okay, you want to try and get from 2 to 3. Now, what I have a lot of people do is they try and save themselves a lot of work. They would like totally backtrack and then come this way. I don't know why you would do that when there, there's perfectly good other routes that you could creatively find, okay, to get from one place to the other. And so all you have to do is pick some reasonable routes. From 4 to 5 is probably the trickiest one. Okay, there's kind of a little pass here that you could go through. Okay, and then you might have to zigzag your way down. Okay, because there's a few cliffs that you'll have to avoid. Okay, stuff like that. I'm not really worried too much about what route you pick, just about the calculations you do with it. But if you're just doing this and saying I'm going to go here and then there and then here, you're not going to do that. Okay. You do have to pick reasonable routes, and you don't have a helicopter, so that's not the way you're going. All right? Whoops. Okay, so that's finding your routes. Then the calculations and measurements you have to make, okay? Or some rules you have to follow, okay? Rules that you have to follow here are that altitude affects speed. Okay? So if you are on a trail, so on a dotted line, and below the tree line, that would be in the green area on the map, okay? You can walk at 1.5 meters per second. If you are on a trail and above the tree line, you can only walk at 1.2 meters per second. Why so much slower? Yes, you're going to be shorter of breath because at altitude there's less oxygen available and it's just plain harder to do things, okay? At altitude, if you ever watched anybody climb Mount Everest, okay, when they're getting near the top, they take like one step and then they stop. And it's like they've just run 100 meters full bore. Okay, and they just sit there and they breathe heavy, and then they take one more step and then they breathe some more. It's hard, okay, and that's with supplemental oxygen. Okay, imagine like trying to do this, and some crazy people do. Okay, get to the top of Everest without supplemental oxygen. That's impressive and crazy. Okay, but for us, it's going to affect us a little bit. 0.3 meters per second. All right. Second rule, the Bushwacker rule. Okay, so if you go off trail, and you're going to have to, okay, that's going to affect your speed because now there's going to be obstacles in the way. Even if you have a machete, you still have to swing it back and forth, so you're going to slow down. Okay, so below the tree line, so in that darker shaded area, the green part, okay, you can only make 0.75 meters per second off trail. Above the tree line, you can actually go faster. Why? Because there's no trees. Okay, so yeah, even though it's at higher altitude, you don't have anything to go around or through. Okay, so you can go a little bit faster. So that's something else to keep in mind in terms of speed. Okay, and then the third rule is the silly salmon rule. Okay, you are not a fish, so anytime you cross a stream, not on a trail, because on a trail, what would there be? A bridge, so it doesn't count. Okay, but if you're off trail and you have to cross a river, you have to add 15 minutes to your total time for the day. I'm going to talk about how you calculate your total time for the day here in a minute. But you'll have to add 15 minutes every time you cross one of those because it's not something you take lightly if you like being like warm and dry. All right, so the second part of this activity is to practice using your kinematic skills, okay, and your V equals D over T. It's pretty simple calculations, okay? For each day, you need to measure the distance traveled. All right, here's how you're going to do that. So we've drawn our route on the map. Okay, what you're going to do is take like a shoelace or a headphone cord works pretty good, okay, or like a power adapter cord because they can take the shape of this trail. Because I don't know if you've ever tried to measure curved lines with a ruler, but it's very difficult. Okay, so this can help you out. What you do is you put the string on the trail. It's hard for me because it's vertical and gravity's messing with me here. Okay, but you make it take the shape of your trail. And then you pinch one end and then the other. And now if you measure that with a ruler, you know exactly how far you've gone. Okay, Everybody follow me on that? It's hard for me to demonstrate up here, but it's easy on a sheet of paper on the desk, okay? Because the string will stay where you put it, okay? All right, so that's how you'll measure the distance. Now, something to keep in mind. That's going to give you the distance in centimeters. Is that how far you went? No. Okay, this is a map. And its scale is 1 to 50,000. That means 1 centimeter on the map is 500 meters in reality. So whatever you get, you got to multiply it by 500, and you'll have it in meters. Okay, so you'll have to do that conversion, okay, to get your distance in meters. All right, so that's the first thing. You're going to have that for each day and over the whole trip, which is easy. You just add the 5 days together.
Do you have rulers you can...
I'll put some meter sticks out.
Oh, okay.
Okay, so you're going to have the distance for each day measured and recorded, and the total trip distance recorded, okay, which is just adding them all together. All right, the next thing you're going to have is your displacement for each day. Okay, so if I want to get the displacement for day 1, I just take, well, I cheat because I have a cool tool that will do this for me, but you'll have to use a ruler and a pencil, okay, and draw a straight line from the starting point for that day to the ending point for that day. All right, now if I measure that with my ruler, multiply it by 500, I have my magnitude of my displacement. What else do I need? Direction. Okay, so how do I get that? Well, the answer is, okay, that I've got grid lines on my map. They go north and south and east and west. So all I have to do is draw vector components that are parallel to those grid lines, and I'll have a triangle that I can use to get the angle. Right? You don't have to convert the sides of that triangle into meters in order to get the angle. Right? You just have to get the angle using trigonometry. Measure at least one of those sides, okay? And you'll be able to calculate the angle with your hypotenuse. Okay? But I want to see those triangles drawn on there, okay, so I can verify on your map what you've been doing. Okay? So when this is all done, what I should see is a route drawn and a triangle for each day. Okay? And I'll want to see the numbers recorded on a separate sheet. Okay, so I'll have distance and displacement for each day. All right, next thing, total time for each day. Okay. Here's how you calculate total time. Use V equals D over T. You already measured the distance, okay, and on day 1 it's easy because you're going to be on a trail walking at 1.5 meters per second for that entire distance. Okay, so that's pretty easy. I can calculate how long that takes, and I'm done. On a day where you're going to be on the trail and off the trail, you're going to have different speeds. So what I would suggest would be that you use different colors. Okay? So if I'm looking at going from 1 to 2, there's a trail here, so I can follow this trail until I get to about there, and then I'm off trail. So I would use a different color. Okay? Until I can meet up with the trail again, okay? And then I can follow. I don't even know if that's exactly where it is because I can't see it on my map. Okay, and I would have that for day 2. So I could calculate how long this part takes, the same way I did for day 1, V equals D over T. For this part, V equals D over T, but I would use the slower 1.2 meters per second, or sorry, 0.75 meters per second because I'm in the trees and not on the trail. Okay, and I cross a couple of rivers here while I'm off the trail. For each one of those, I got to add 15 minutes to whatever I calculate V equals D over T to be. Okay? Everyone follow me on that. Then I add all those times together, I got the total time for the day. Okay? Everybody good with that? Once you have the total time for the day, you're going to do your 4th and 5th thing. Yeah, 4th and 5th thing for each day, which is calculate the average speed and average velocity, which is just a V equals D over T calculation again. Okay, your average speed, total distance over total time. Okay, for day 1, that's going to be really easy because you only walk at 1 speed all day. Okay, but for day 2, it's going to be a little bit different. Okay, and then your average velocity, your total displacement divided by the total time that you already calculated. Right, so that's what I'm going to want to see for each day: the map, the triangles, and displacement, distance, time, speed, and velocity for each day. Okay, I'm also gonna wanna see all those things for the whole trip. Okay, so when you're all done, you're gonna have to do one more triangle, right, for the total trip for displacement and velocity. Okay, now that's gonna involve the total time for the entire trip, but you don't have to include time you're not walking. Okay, obviously, this would take days and we would just go 24 hours. Well, no, we weren't actually walking for 24 hours. You slept somewhere in there. Okay. All right, everybody understand what they're doing here? Nothing like mathematically difficult here. Okay, it's just something to kind of review stuff that we did way at the beginning of the unit a long time ago, okay, before we did our test. And it's kind of an easy way to get some easy marks. And, get some social interaction with other people. Okay, but through a mask. Don't forget that. Okay, so you can get together with some people in a group, okay? Just try and make sure everybody's included, okay? If not, I will make sure that everybody gets included. I would say for this, guys, a couple of suggestions. Have one person who has like the neatest writing and stuff, have them do the map that you're gonna hand in as a group, okay? Everybody then can split up the work, okay? Maybe somebody does day 1 and 2, somebody else does day 3 and 4, somebody does the whole trip and the map, okay? Or something along those lines, just so everybody's contributing something, okay? So divide and conquer, okay, on this, make sure everybody's got a job. And then at the end, you're gonna submit it all together, but maybe it's, my page from day 1 and 2, your page from 3 and 4, and so on. Okay, it's okay if it's not all done by one person, okay, or all uniform. That's fine, because I kind of expect that for this. All right, so make sure you split up the work and assign stuff to everybody. As you're working, though, make sure everybody is making their own copy of the map, okay? Because if somebody ends up being sick on the day when it's due and they're not here to submit the map, someone else can submit a map because they'll have had the same copy. Okay, so everyone will have a copy of the map that way. All right. So I'll let you guys pick your groups and you can get going here. If anybody needs a group, let me know and I'll make sure you go.